Welcome back to Anagalactic, or if this is your first time, welcome to Anagalactic. My station is called AE. Today is a Tuesday, May 19th, 2026, and you'll see on our high-tech whiteboard back here two words, which if you can't read that, perhaps it's on a small screen. It says axiom and ideal. Two five-letter words by coincidence. Axiom and ideal. Why do I bring that up on my science channel, which is mostly devoted to geometry? It's because we're talking about the geometry of reality right now. Pardon this hat, but it is still early morning here. This promises to be a hot day, which is very good for me because of arthritis. So I may look a little disheveled. It's a little difficult for me to get started in the morning, but I want this to be informal. Most of my 1,600 presentations over the past 4 years have been rather carefully prepared for a one-man operation anyway, for a man who's doing continuous research and has been for a while. So I do claim to be a proselyte scientist. I am a beginner scientist. I do claim that we all are basically in the same boat compared with what we might know. Now, what I will be dealing with today has been on my mind for years. It is a province of philosophy, which I normally avoid. I basically am catching up with science, and so mostly I'm interested in discoveries, facts, and of course structure, which is the essence of geometry, is structure, which, by the way, is not particles or waves. So structure is part of a meta system. It's a conceptual framework. So I consider structure, by which I mean explicitly geometry. That is the study of relationships, and that is virtually synonymous with structure. These are relationships that form structures, which are quite different than numbers, and yet there is a superposition there which I have discovered. It's always been intuited. Now, I just summarized my work that began 4 years ago with a rather simple discovery, and I did research my discovery. What was my discovery that I claim is a brand new discovery in geometry? Essentially, the chatbots gave me the clue to the nomenclature that describes my discovery, which can be described in several ways. Why would I say it's simple if it can be described in several ways? And what does this have to do with philosophy and axiom and ideal? These are attempts to structuralize science. That the concept of an axiom is a beginning point for a logical structure. And a logical structure is a slightly different use of the word structure, because the word structure is extremely broad-based, because it describes virtually everything that is not measurable, although there is an overlap there. So all of this is rather abstruse, rather abstract. Welcome to the world of cutting-edge science. What I will be talking about today, now that I've used 4 minutes to bracket what we're going to be doing, this is not quite what I began with. So I'm going to summarize what I began with, which was an extremely simple discovery, and how that has evolved over the past 4 years into my present position of dealing with a philosophical basis for science, which is quite a topic. I will be capitalizing today on the work of Dr. Bernardo Kastrup, whom you may or may not have heard of, but you very well might have heard of Bernardo Kastrup. He is probably the foremost voice for at least 20 years. What I mean this in the best sense, that he is the spokesman of a rational approach to reality. He gives it a name, and it uses philosophical terms. Now, I have fully investigated Dr. Kastrup's work to the threshold that I'm able to achieve at this point, because one could spend the rest of one's life, as many men have, including Dr. Tim Maudlin, who is in some ways similar to Dr. Kastrup in that they both have degrees in the philosophy of science, which means that they're devoted to it. Well, you can spend your whole life doing that. Does it matter? Does it have an effect? I don't mean that. I just mean to bring out, using a common technique called a quiz question, to get you to think about it. Because you do need to be specific. And in the recent interview, within the past few years, between Dr. Kastrup and Dr. Susan Blackmore, who were interviewed together on the Kurt J. Mungle show, a very well done presentation, which is quite lengthy, but I have been listening to it. I'm about halfway through it, because this is where I'm at in my research into this tremendous cutting-edge field, which has really captured the minds and hearts, the spirits, or however you want to put it. It's top of the list. Absolutely top of the list is the definition of consciousness. And to say that that is the topic at hand, the definition of consciousness, is to so simplify what is being discussed that it's quite deceptive. Because you would think that that's quite a simple question, because it can be stated simply. Now, science is the art of simplifying understanding. Understanding, of course, comes from knowledge. Well, all of this gets into processes and structures which are already in place. And this is exactly what Dr. Blackmore and Dr. Kastrup deal with, is what does it mean to have presuppositions about anything? And is that an infinite regression? This directly bears on the very nature of what science is good for. What is its purpose? What is its possible goal or goals? This has to do with the nature of reality, the virtuality of consciousness. Is it phenomenological? Is it based on physics? Is it physical? And all of this just exfoliates in all directions. So this is a sort of a universalist approach to hard science. Hard science is, of course, what you and I would prefer, which is that if you have a question, you get a straightforward answer. There is a limit to that because of the infinite nature of the universe. Now we're talking about an abstract concept called infinity. This does have a geometric representation. We're also talking about imaginarity, and this comes up quite strongly in the conversation between Dr. Blackmore and Dr. Kastrup, which is dissociative phenomena, which has to do with boundaries between phenomenological conceptions. And it has a direct bearing on the mind-body problem and what is called the hard problem. All of this just branches in every direction at once. So it is extremely difficult to focus on what's ever being said at any time. My goal today is to approach the tremendous work of Dr. Kastrup, which is now virtually legendary, and I at first was put off by it. When I first encountered Dr. Kastrup's philosophy, it was in a context where he was pitted in a debate against Dr. Tim Maudlin. This was Kurt J. Mungle's fiasco. It could have ended him as a presence on YouTube. It was a monumental failure, directly attributable to J. Mungle's incompetence in arranging the meeting between these two great minds. I will give you just a little bit of background so you know why I'm concentrating on this one interview with Kurt Jaimungal, who is one of my heroes. I criticize him mercilessly for one reason and one reason only. That is science. Merciless criticism. But then there are meetings of minds. Now, I first heard of Dr. Kastrup when I was researching Dr. Maudlin's work on quantum mechanics, which in some ways is cutting edge. He has an entire institute which he has founded, and which now has a base on the island of Hvar in the Adriatic Sea. And Dr. Maudlin is no small fish. And I mercilessly criticized him and mercilessly criticized Dr. Kastrup and their host, Jaimungal, who botched the whole meeting. The way I found out about Kastrup, the first time I may have heard his name or seen his name, but I paid no attention to it because it was out of the context of my research and I just had to ignore it. But when I was researching Maudlin's work, which I think is top-notch, I own 2 of his books, and I've read many of his papers, and I've seen many of the interviews conducted with this really amazing exponent of quantum mechanics on all sides. In other words, he's well-rounded. He does have a PhD in the philosophy of science, as does Kastrup. Now, when I was researching Tim, who is one of my heroes, as is Dr. Kastrup, as all these people are my heroes. But I, too, am a flesh and blood scientist, and I am trying to come up with human answers as well as scientific answers, which means I am going to have a subjective opinion at any time, which I think a scientist should be bold to put forward. That is, where are you coming from, sir? Why are you speaking down to us, which can be good if it's a good source? You see, whom can you trust? Time is limited. We all are constrained by time limits. We have to be selective. But when a subject such as the philosophy of science, in any context, comes up, it exfoliates in all directions at once instantly. Extremely difficult to corral. It's like trying to push around a blob of mercury. It's just going to change shape no matter how you do it. That may be a very poor analogy, but I think you see my point. This is the opposite of precision science. It's absolutely the opposite. It's infinite science. It's where we encounter infinity. It's also where we encounter imaginarity. And these are 2 terms that I have made significant discoveries in the geometric interpretation of those 2 terms or concepts. That they do have a geometric representation. There is such a thing as imaginary space. There is also such a thing as infinite space. And in both cases, you're dealing with something that is beyond direct perception. So you're already dealing in la-la land, loopy land. It is part of reality, though. And that's a direct contradiction. So that is the whole nature of this level. This is the cutting edge, you understand. This could be said, I believe it would be safe to say it this in context. This is the cutting edge of human thought itself. The introspection of the human mind into its own workings. And that's really not stating it very completely. It's very difficult to state anything in this context completely because you're dealing with the infinite. You're dealing with something that's imaginary. What does it mean that we can conceptualize even the concept of imaginarity? If it's imaginary, you shouldn't be able to conceptualize it at all. Is that true? Well, you see, all of this gets into a convolute and involute you have to start using philosophical terms, even to talk about what you're talking about. Again, we're getting involved in a regression, and that leads us to our first word, axiom. To complete my story of how I encountered Dr. Kastrup, it was when I was reading comments about an interview with Tim Maudlin. These are rather high level commentators as commentators go. One of the high level commentators. So this guy had already commented, and I really liked his comments. And then he said, and this is it, he said, we need to get Tim Maudlin with Bernardo Kastrup. And I recognized that name, Bernardo Kastrup. Immediately, I was dubious of this man strictly out of prejudice because I liked Tim Maudlin. And the way this guy was bringing it up is we need to get Tim Maudlin in the lion's mouth, or get these two into the arena, into the cage, and duke it out, which means that this guy was implying, as far as I could tell, that Kastrup would definitely want to take Tim Maudlin to the cleaners. So I'm like, not sure I like this Kastrup fellow. Well, sorry, I am human. I realize now that that was really just my human foible coming to the surface. Because I'm human, I had my favorites. And I like Tim Maudlin, Daddy-O. Don't you be speaking up against... So this guy threw this out. And then there was a favorable response. Yeah, that would be something. So these commentators already knew a lot about Kastrup. Certainly enough to say, right out of the blue, they just pulled this out of their hat. We need to get Maudlin in the cage with Kastrup. So... So then I forgot about it because I didn't have time. I was doing something else I couldn't afford to, like... I thought about it. I thought maybe I should learn about Kastrup. I may have checked something and went, no, he's a philosopher, and Maudlin is already too much of a philosopher for my liking because I don't understand what he's saying, because he uses these words that I don't know. And this is what these guys do, because that's what they do. I'm not saying it's bad, I'm saying it's above me. So that's why I didn't investigate Kastrup at that time. I think I can be forgiven in a court of law, extenuating circumstances. But I look back, I might have checked out Kastrup at that time. Well, I know a lot about Kastrup now. Oh, he's top-notch, all right. But here's what happened. It was just a few months later. This is only within the past 2 years that this happened. A debate between Maudlin and Kastrup. And I remembered this guy's comment from months before. I went, holy moly. I was so excited. Well, so were thousands of other people, it turns out. And this was a massively watched... I mean, we were all subscribers to Jai Mungal. We, who are into the pudding... We know that Jai Mungal is a source. He's good. Jai Mungal is the best. Oh my God, Jai Mungal is hosting the Kastrup Maudlin debate. It was a fiasco. Neither of these guys is a nutcase, but if you didn't know either man, and I didn't know Kastrup, they both disgraced themselves absolutely. And Jai Mungal was almost in tears. So I made a comment in one of his subsequent videos. Yeah, it looks like that horrible fiasco of a so-called debate, it looks like that was pulled. And Jai Mungal read it. He read the comment that I put. So, which it impresses me because it takes time to read those comments. It could be hundreds, even thousands. Well, he read mine, and he replied to me directly, which I was just flabbergasted. He said, no, I didn't pull it. It's still out there. And he and I have had kind of an exchange. He kind of knows, or he knew who I was for a while. Because I was reaching out to Jai Mungal really in a roundabout way to see if he could interview me. Well, I told you, Mania. It's really, he's way too busy to deal with a small fish like me, and I knew it. But if you're desperate, which you are if you made a discovery, if you're me, right? So, you know, I'm not a machine, okay? All right. All right, so why do I have axiom and ideal here? First of all, let me just give you the epilogue to what transpired there. What you should see that video. It's really, I don't know. It's worth seeing because you just should see what it's like for when something goes wrong. And I blame Jai Mungle, but only in a just cold, cruel, objective sense. Everybody makes mistakes. In fact, I have said, and I will say again right now, if you're not making mistakes, you're not at the top. You will make mistakes if you're at the cutting edge. And Jai Mungle, trying his damnedest to be the best he can, really stepped in a giant pile of doo-doo. And the reason I claimed that it was his fault, although I really don't think that this is fair of me, it was just an immediate assessment. You know, prima facie, looks like you blew it, Kurt. No, 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 you have to get the court convened and let's look at everything. No, no, you just did what I do and what we all do, and the case dismissed. But it still happened. It was a fiasco. And what could have been done to avoid the fiasco, which Kurt is fully aware of now, is that you have to have a preliminary meeting, first of all, with each individual person who's going to be in the debate. But if it can be arranged, a direct preliminary meeting so that they can actually kind of rehearse. Now, that can't always be done in this fast-paced world. Sorry, but I did just wake up. I have to just prime myself here for this fantastic philosophical incursion into reality. Whatever we're about to do, don't worry, this is going to be good. I have the answer. I always have the answer because of this geometry that I discovered. And I will be revealing that to you so you see how all this fits, so that I can simplify this entire morass of what is consciousness, which again is just emblematic of a million questions. It's really fractal. It's really asymptotically infinite. It's just, we're reaching too far with the tools we have. And Kastrup is most aware of that. So is Susan Blackmore. And the reason I have this inset window is these are the comments that I made while listening. Just give you an idea how my thought process go. I was just writing this down while listening. Susan Blackmore is courting regression to imaginarity, which is a physical property of the cosmos. You see, I discovered that. Imaginarity is physical. There is a physical imaginary realm. Does that sound spooky? I would assume it does, but hang on. She professes fear. She still denies what Kastrup asserts. Kastrup goes to supernaturality. Now, I want to just pause there. I believe in a universe that has a context. That's a huge statement, but I don't want it to be huge. I just want it to be introductory to what I'm going to say. That I believe, I theorize, I visualize in some way that the universe as a physical object has a superspace. That if you're going to say that the universe is a thing, in the most abstract sense of thing, it doesn't have to be a material thing, but it is a thing in the sense we have a word for it, and we can see it. We can see that the universe is a thing. I don't think anybody can argue with that. Although, of course, there is a completely opposite point of view. No, you're totally missing the point. The universe is not even a thing. It gets that far. How justified is that form of extrapolation? It ends up in an infinite regression. But in geometry, we can prove that if you have a space, which may be a space which is meant to represent physical space, which would be what we call volume space, or if you wish to go to space-time, it has an imaginary component. That's what space-time means. It's an extension of physical spatiality, which is considered to have 3 linear dimensions, into a 4 linear dimension system where one of the dimensions is imaginary. It turns out that may be Einstein's greatest discovery. I could definitely make a case for that, because that means that the universe is part imaginary, that is not a projection of the human mind. Instead, it is something that we can perceive, but that leads to a direct contradiction, because the definition of infinity is that it is imaginary, which means that you can't see it. So this is metavision, which forms a layer. And so now you're getting toward the infinite recursion, because if the physical universe has a superspace that is also physical, as I believe can be proved now with my geometry, that Einstein was correct, that the addition of an imaginary dimension is necessary in order to reach a new threshold of our ability to conceptualize reality, which is the goal of science, which goes beyond physicality and actually now extends into something that can at least be indirectly defined, which is that a part of what we call the physical universe is not only non-physical, it's not conceivable. It could only be indirectly pointed at, such as the Buddha, in order to explain his message, simply in one lecture pointed at a flower. Now that may be a legend, but it's a very popular legend, maybe classified as a meme, which Susan Blackmore is into, memes. So am I. I think the concept of a meme is an extremely powerful concept. But you see how this just exfoliates in all directions. What I'd like to do now is pause. After only 35 minutes of essentially lead-up information to what I'd like to get into, I'd like to keep this under an hour. And I want to start with the word axiom, but there has to be a context. So the context has to do with that little inset window, which I will now simply turn off and refocus our attention here so that you're just looking at me. Axiom. What does that have to do with the theory of consciousness, or the structure of the universe, or with anything that we are attempting to penetrate, which really is the nature of consciousness here? What I found, again, but really well drawn out in this well-conducted interface between two great minds, Kastrup and Blackmore, are definitely palpably real. It's just that they're so high-flying. It's almost dizzying to try to keep up with them. It's not just that they have words that you and I don't normally use, or even have looked up, in my case, but there's layers on top that they're dealing with constructs and superposed hierarchical levels of evaluation that just keep piling up. And it's hard enough for you and I to jump into the philosophy nomenclature. But then when they put these ideas together in really complex sentences, paragraphs, the way they speak to each other is very difficult to follow because they are really in another realm. And I find that to be most interesting in itself. That I observe that as a phenomenon that I'm forced to deal with is that this seems to be a natural tendency in science. It certainly appears in quantum mechanics. That in our effort to simplify to a solution will be simple. It can be understood because it can be proved. So that is the nature of what is meant by science should be simple. Because you should have a rational question that will have a rational answer. Well, when you're probing the limits towards imaginarity and infinity, there's a limit beyond which you cannot go. In this paradigm, as I'm proposing really a framework of approach, the nature of the limit of what we can even do or achieve has two aspects, one going into the quantum paradox, which is where we can no longer go further in, and the opposite going out, which is most familiar to us, certainly as children, that we gain a more or less direct perception of what is infinity by gazing into the night sky. How far does it go? Well, that goes right into the philosophy realm. How far does the universe extend? Is it infinite? That's quite a question. I solved that question. That wasn't my goal, but it just came out in the exfoliation from this geometry, which is simply the geometry of curvature instead of the geometry of the straight line. It's the other geometry, which I discovered. It's intrinsic geometry. The geometry of curvature is intrinsic rather than extrinsic, which means it's not a scaffolding imposed on space. That the nature of curvature is the nature of space. It's not linear. Einstein proved that, and it's a wonder that nobody has ever thought of what I thought of. Because they're saying now that gravity is not a force because space-time is curved, which means that space has a characteristic. It's curved. Well, how can then linear algebra or linear geometry, or in fact linear mathematics, deal with that when it's not linear? Well, the answer to the question is there is another geometry that is non-linear, that is totally superposed with linear geometry. In other words, there are two alternative ways of looking at the universe, either as curvature or as the special case of zero curvature. A zero curvature line is a straight line. All other lines are curved. So could you even say there is such thing as a straight line? Well, Euclid proved that you can do that axiomatically, that you can begin with a line. But if you do begin with a line, as he began with the first two sentences and elements, you must begin with a point, or you'll find out that your line is meaningless. So the line has to be composed of points. That's called Euclidean geometry. And it's based on a process which is just as famous as the linear geometry that Euclid basically systematized. And the other discovery, which is equally important as the discovery itself of the axiomatization of linear space, is the axiomatic process. The axiomatic process, which he used to prove what he said is true. And so the axiom is a step. in that process. And it is the first step. Ultimately, you may have to derive your axiom, and Euclid actually had to do that. What he wanted to do was to define the straight line, which I now can say is a zero curvature real line. The universe only uses curved lines, although there's a footnote because it's superpositional. We do take a straight line distance to a star. And I won't go into that further, but I've given several lectures on that, on how that could be considered an illusion. Now, Susan Blackmore is an illusionist, which she fully understands that that word is a dangerous word to use. So what is an axiom? When Euclid went to define the line, he began by defining a point, which is not what he wanted to define. But he figured out that he had to have an axiomatic statement that would support his definition of a line, which he could not axiomatize. Because if he began by defining a line as being 1D, which is how he defined it, in other words, it has length but no breadth or height. Or you could say length but no, it lacks the other two spatial dimensions. That's what he wanted to define. But if he axiomatized the line as a 1D object, he would be leaving out a step, because how did you get the line? How did you draw it? Well, the way he axiomatized his line was by axiomatizing the point, which is the intrinsic component of the line, that the line is nothing but points. Even if you just take a line ray, which is just going in one direction, or if you take the double ray, which is how the line is conceived as a full object going to two infinities, interesting statement, or a line segment, which is cut off, that's called a distance. And that's what he actually wanted mathematically, was distance as a metric. So it's the metric of the line is distance. But how do you metricize the line without a point? You can't. And so he figured that out. And so he began to define the line by axiomatizing the point. And so what does it mean to axiomatize a statement? It means that it can't be proved. It has no definition. That's what an axiom is. You just say so. And that leads to an extraordinary trap. Because when you do that, you're still leaving out a step, which I discovered. That Euclid was very primitive. He made a good deduction that he could not axiomatize the line without the point. And so he chose to axiomatize the point. That's a mistake that I discovered. I discovered the mistake in Euclidean axiomatization, which is the definition of the point. Because in order to define the point, according to what he figured out, so this is a step backwards from what he had figured out. And this figuring out involves both deduction and induction, which I've proved are inseparable. Whenever you do one, you do the other, but they are two sides of the same thing. So he wanted the line, but he needed the point. But what he should have done, which I proved can be done and is the only right thing to do, unless you're going to be satisfied with linearization of space, which is no longer adequate. We need curvature space. So what he did was, he defined the point so that it could only be defined on a line. So the point that he axiomatized is 0D. He didn't use the term 1D and 0D, but it's exactly what we would call 1D and 0D. So he jumped from 1 to 0. But what he did is that he axiomatized nullity, because the point, being the axiomatic object, has no existence. It's not there. It can be proved using the linear extrapolation, the very next step, that once you have a line that's made of points, now you can define the point in context of the line. And that's the only correct definition of a point. But you see the problem. Perhaps the point is only useful for distance, whereas the universe cannot be axiomatized so simply, that perhaps it has a different axiomatization. It does. And it depends on the axiomatization of the point. What he might have done, and which I've given several video lectures on what I did, as a result of my discovery of curvature geometry, it was shown to me. It wasn't something that I really thought up. It's just that in my postulate sequence, that is my series of proofs for what I discovered, which is basically curvature geometry, really the reparameterization of the plane. Very interesting thing to say, because the plane we conceive as a 2D object. Well, I don't. The plane must be conceived as if I were Euclid, and instead of trying to define a line, I'm trying to define a plane. And when I do that, to define a plane, which is how we see, by the way, that's been proved in physiology. That's why linear algebra is so natural to us, is because we see a flat screen image. We see 2D. We interpret the third dimension called depth, but we see a photograph. And how we see is a series of snapshots of a 2D flat screen is what we call it. So that's the nature of the plane, is it's much closer to human reality than the line. But do you even need the line? Not if you parameterize, not if you axiomatize the point correctly, which Euclid did not. Although it's superpositional, it actually works for extrinsic geometry, which is all science uses. I discovered intrinsic geometry, which begins with a re-axiomatization of the point. I do not begin with the point. I begin with the plane, but I'm forced to take a step backwards in order to define the plane. So what is the plane? Disregarding Euclid, what could you say about the plane? Well, it's infinite. But it's not infinite on 2 points, which is what Euclid did. That begins the systematic linearization of a volume space, is with 2 infinities that are polar opposites. I don't start that way. I start with a plane as a plane, which does not have a linear aspect. Does it have an aspect? Yes, infinity, going out, which I proved is circular. So the correct line to begin with is the circle, because that bounds a space. So then you would have to ask what is outside the space and what is inside the space. And that led to the greatest discovery since Euclid. So that's tooting my own horn a little. And what this leads up to, what I'm trying to put forward for your consideration, is that having developed that geometry, I was able to rationalize infinity and prove that imaginarity is physical. And those are 2 separate statements. Infinity can be defined as spatial imaginarity because we can't see infinity. Does that mean it doesn't exist? No, we can see it exists because we can see that we can't see it. And that's somewhat of a contradiction. But that then objectifies imaginary space. What I was able to do was show that infinity has the characteristic of imaginarity, But it has another characteristic, is that it forms it can be constructed in a nonlinear way such that the outside of the circle, the outside of the infinite circle, I should say, the outside of the infinite circle has to be imaginary. Therefore, what is inside the infinite circle is reality. That is, we can measure it, we can see it, we can find consciousness in it somehow, but it's inside the circle, which means inside the volume sphere. So is the universe actually spherical? If you say so, which I've proved you should, if you say that the universe is spherical, you're still left with the question of what is outside. But now it's not two polar infinities in three different orientations, making 6-point infinities for volume space. That's enormously, that introduces a huge overhead of mathematics. And I won't go into that, but I have in several video lecture series. So that's what I've been working on, is developing this new geometry to see if it helps us in physics. Yes, it does, enormously, in ways that linear mathematics simply will never be able to do. We've hamstrung ourselves with systematic linearity, and space-time is simply the extension of that inadequate scaffolding. It's an extrinsic geometry. Space-time is extrinsic. So you have to find some way to introduce curvature into it. The way Einstein did that with relativity was with hypercalculus. At the inner limit, trying to figure out what makes things tick at the quantum level, which involves a contradiction at several levels, called the quantum paradox, you have a conjugal problem that your mathematics simply cannot model what you need to model. And the one who reached furthest until Bohm was Dirac. Dirac, in order to more closely unify the quantum mechanical system, which contains a paradox of probability, which Einstein would not stand for, and he's right. You can't have both science and probability, although there's a footnote. But we won't go into that. I'm simply showing that spatial infinity is imaginary, but that's going out. What happens when you go in is you encounter the conjugal limit. It's not polaric, it's conjugal. Going out, it's expansive spherically in volume space, in real space. What we would call space is spherical. Space-time is hyperspherical, but it's hyperbolically hyperspherical. And what Einstein did is he invented hypercalculus to curve it, because the lines don't curve. It's a grid of 4 lines. Now what Dirac did is he examined the Schrödinger equation. Really, Heisenberg and Schrödinger, and there were a couple of other men who had successfully enough mathematized the phenomena. But with that paradox, there's a limit to which you can't go any further, which is essentially the wave-particle duality. But really, Heisenberg nailed it. He said you can't get both position and momentum at the Planck scale, which really is introducing more than I wish to discuss here, and we only have 3 minutes left. I will now summarize for the next lecture. My use of the word axiom is now the most appropriate use of that system of axiomatization, that I discovered the correct axiomatization of physical space, so that it is intrinsic and it's curved. And the perfect curve, of course, is the sphere, which means that outside is hyperspheric. What about going in? Can you reach the point at the center? There has to be a point at the center, because if you have a sphere, no matter how big, it has a center. Is that a point? Yes, and that's the only point in the system. There are no other points. And with that, I'm going to have to desist for now. I thank you for your patience through this. I know I didn't get into the debate, which I haven't finished listening to, by the way, but the debate between these two great scientists featuring Bernardo Kastrup, who is now in my crosshairs. I mean that extremely positively. Dr. Kastrup has my full attention now, because I saw some of his videos over the past 2 days as part of progressively researching into his work, which I find absolutely remarkable. Absolutely, he's pushing the envelope in the right direction, and I think that he has made the breakthrough, which is saying a lot from my point of view, because I already made this breakthrough, but in a different context, in the context of physical space. That I discovered the same thing Kastrup discovered, but Kastrup discovered it in spiritual space. And I use that word guardedly, but provocatively. The right word, according to your predilections, may not be spiritual, but he deals with the human soul, and that man is a religious man, which is extremely rare at his level. I can't speak for Maudlin, I can't speak for any of the others, except 99 out of 100 faces you see on YouTube that are making hand over fist dollars, basically just dealing with a fractalized system for your entertainment with no solutions. Those men do not have any religious basis whatsoever in their view or their life. Kastrup does, and that is extremely valuable. Keep looking up. We'll be right back. Thank you again, those of you who have tuned in. It means a lot to me. Thank you very much.